In today's class, we will study measures of dispersion. This topic is present in the BMS third phase in that research methodology and medical statistic syllabus in that 16th chapter, and this is the second part of the measures of dispersion deviation. Now, what is here measure of dispersion deviation here? The dispersion is nothing but how much the data is scattered from the central value. In the previous classes, we studied that in the medical field research, we are concentrated on central value, that is central tendency, that how much data is stable, that center, how much measures are there. Now, in this class, we will try to understand that from the center, that how much data is dispersed or scattered from the central value. That is helpful for the understanding in the medical field as well as in the research also. Now, first of all, we will study the introduction. Okay, first of all, in this class, we will study two or three topics. First topic is the range, second one is the variance, and third one is the coefficient of variation. We will cover three topics in the today's class. The first of all, introduction of the dispersion of measures of dispersion. Dispersion means measuring the how much data is scattered. That is the measures of dispersion. Here, the introduction dispersion refers to the extent of to which observation are spread or scattered around the central value. From the center, how much it is spread, that value is called as a measures of dispersion. The measures of dispersion helps to understand the variability and consistency of medical data. Why we are using? Because it helps to understand the variability, how much variability in there in the data, as well as how much consistent it is the data it is that in the medical field. It is helpful for understanding. Okay, now one by one we will study. The first topic is a range. Range is the difference between the largest and smallest observation in the data set. You know, in some patients, some data you are collected, the highest value and lowest value, that is highest observation, lowest observation, the difference itself is called as a range. The formula is the range is nothing but the range is equal to maximum value minus minimum value. Okay, now for easy understanding, we will take one example for here, medical exercise here. Okay, if you have considered you are taking the pulse rate, the pulse rate of 5 patients are 72, 76, 80, 84, 88 beats per minute it is there. Then maximum value here 88 and minimum value is the 72. If you put the value in the data, then the range, the formula, the maximum value is 88 and minus minimum value 72. Okay, if you will do calculation, then 16 beat per minute, it will the answer. It means the range, the difference is the from 16 beat per minute, there is a difference, it is there. Okay, like that we are using the range in our medical field. The next another thing, limitation. What are the limitations here? The range depends only on the extreme value. It is only extreme value, the middle value it is not considering. That is the one of the drawback here, and it is therefore greatly affected by the outliers. This is the limitations. Now the second topic is the variance. What is here variance? Variance is the average of the square deviation. See here, this is the average of square deviation of observation from their mean. From their mean, it is the average of square deviation is called as a variance. It indicates the amount of variability in the data. Okay, here it indicating the amount of how much variability in the data, that is indicating. Now here for calculate the variance, there is a formula, it is there. Okay, sigma square, it is also called standard deviation square, that is sigma square is equal to sigma or some bracket x minus x bar whole square divided by n. This is the formula, it is there. Whereas x means here individual observation. The individual observation we are mentioning here x, and mean is the all observations, the middle point mean value, that is the x bar. Now n here, the number of observation, the how many patients you are taken, that is the numbers. The number of observation is the n. Okay, consider one medical example here. If you are taking the blood glucose here, then the 3 patients blood glucose values comes around 90, 100, 110. Then here if you total and divide the value, then mean it will come 90 plus 100 plus 110 divided by 3. If you will do, the mean value will come 100 mg. This is the mean. Here the mean is the 100 and individual observation 90, 100, 110. If you put the x is, see here x, the individual observation 90, 100 and 110. If you are dividing the x minus 100, the x minus 100 means x is the 90. 90 minus 100 is equal to minus 10. 100 minus 100 is equal to 0. 110 minus 100 is the plus 10. This is the value. Here the main thing what you are doing here, the variance is the you are doing square here in the, it is given the square of deviation, that is you are doing square. That's why x minus 100 whole square is the main thing here. That's why the 10 square is the minus 10, the 100 is the value, 0 0, and plus 10 square is also 100. If you do the total, then the value will come 200. That's why if you put the value, here the sigma x minus x bar whole square, it will come around 200. And number of patients are 3 here. That's why the n is 3. If you do the calculation, then 62.67 mg by dl whole square, the value it will come. Therefore, the answer is the variance is the here in these observations are 66.67 mg by dl whole square. This is about the variance. Now the third topic is the coefficient of variance. Coefficient of variance means comparing the two variance here. The coefficient of variation is the relative. Relative means that is the relating to one another. Here the coefficient of variation is the relative measures dispersion used to compare the variability of two or more data set. One data set you have taken, another, that is the relation. Here the relative measures, if you are doing dispersion, how much dispersions are there, used to compare the variable two or more data set having different means or units. This is called as a coefficient of measures. Here the formula is the coefficient of variance is the standard deviation divided by mean into or multiplied by 100. This is the formula, it is there. If you put the value here, then the final answer will come. Interpretation, how to interpret, how we will get the result. You know that whenever the low CV, if the final answer is less variation, that is considered as a more constant. The data is considered as a more stable or one of the best data. If high CV, that is the coefficient variation, more variation is there, less consistent. It means that from the center, how much it is scattered, that is called as a less consistent. If from the center, the value is low, that is considered as a more consistent is the. That's why if the more consistent is considered as a stable value. This is the interpretation here. Now we will take the one example in the medical exercise. Suppose two laboratory methods if you are using in the lab, two methods if you are following. The method A, that if you are doing the calculation at the time mean HB, hemoglobin of the patients 12 grams by dl it is coming, and the standard deviation is the 0.6. If you put the value here, the CV is equal to, the standard deviation is 0.6 and HB is the 12 multiplied by 100, that is 5% it will comes. That is the value is coming in the percentage, that's 5%. Another method, if you are doing the method B, means here HB is 10 and SD is standard deviation is 1 gram per dl. If you put the values in the formula, then CV is equal to 1 divided by 10 multiplied by 100, then last values come 10. It means that therefore method A is more consistent because the 5%. The method is more consistent because it has low CV. Suppose the two methods if you are doing, the 5% it will comes, it is considered that in the laboratory, that is the stable data it is there, that method is considered as a good methods or consistent methods. That's why for comparing the two data, the coefficient of variations we are using in the laboratory as well as the medical field research. In other places also we are using this coefficient of variations. Now the last point is the application, where the range variance as well as the coefficient variations we are utilizing in the medical field and research, that we will study. The first is the measuring the variability. Suppose the blood pressure, pulse rate, HB, blood glucose, how much the variable, suppose if you are doing using sphygmomanometer or glucometer, the how much that is the deviating. For measuring the variations, this method is useful. Next is the comparing the consistency of blood, laboratory measures, the lab reports for measuring also we are using. Comparing the variability between different clinical groups. Suppose if you are doing research, then two trials you are doing, one is the placebo and another is the trial drugs. If you are comparing purpose also, coefficient variations, this is helpful. And as also assessing the reliability and consistent research data, how much the data is reliable, trustable, as well as how much it is consistent, it is there. That also for measuring also we are using the coefficient variations, range, as well as the this variance. All the three methods are coming under the dispersion. Hope you understood the today's class. If you understood, please like as well as share to your classmates and subscribe channel. Thank you.